Alright, this is one of the tougher problems from the entire class, honestly. We have to do two things. The first thing we have to do is we have to find the decay rate, K, and then we can go find the time T. Alright, remember these problems start out with A equals A0 e to the kt. So we're going to go find that K value first. Alright, so we start out to find K, you use the half-life to do that. Alright, remember half-life is the amount of time it takes for something to be cut in half, for this carbon-14 to be cut in half. Alright, so we start out and we say that our equation, again, I'll write it again, A equals A0 e to the kt. We know that when time here is 5,600, I have half of what I started with, right? That means I have 1/2 the original amount of carbon-14 when T is 5,600. Alright, so that's the key step you have to realize here, and that lets you cancel the A0, which is how this works. Nobody was around when this leaf got fossilized, but we can tell you how old it is because we know things about how leaves decay and that kind of thing. So we know the leaf is that old. So we have now 1/2 on this side equals e to the 5,600k. Alright, and so to solve this problem now we take the natural log of both sides, and that lets us bring that exponent down. So we have ln of 1/2, or you could use 0.5 if you wanted to, is 5,600k ln e, and ln of e is just 1. Alright, so we have 5,600k equals ln of 1/2. So to solve for k, we divide both sides by 5,600. So I'm going to pull up my calculator and see what I get. And so I'll show you what some calculators do is they give you this in scientific notation because it is such a small number. You get that k is negative 123,776, and another thing here is to get as many decimals as you can. Negative 1.23776. That should be enough. And it says e to the -4. That means times 10 to the -4. So that means move the decimal 4 places back to the left to find out this number. So written without the scientific notation, it means it's 0.0. Let's see, there's going to be 1, 2, 3 zeros in front of that 1. And so some calculators will not show you show it to you this way. You need to understand that that means move the decimal 4 to the left. So it's 0.000123776. So now we can find T. Alright, so now I'm going to use this same equation, but now I have 14% of the original amount, right? It contains 14% of the normal amount. Alright, so 14% of the normal amount, or the original amount in a leaf, is e to the k, and we know k is, sorry, it's negative. I lost my negative back here. Negative 0.000123776 t. A0 cancels again, and we're going to take the ln of both sides again, and that'll let us write ln as 0.14 equals negative 0.000123776 t ln e, and again the ln of e goes away, so we divide by the negative 0.000123776 on both sides. And that should give us our answers. Let me pull out my calculator. And so this is another good example. Just because the way I rounded this, I used 123,776. If I'd used more or less decimals, I might have gotten a different number. I got that T is 15,884. And so pick the number that's closest, and that would be C. Alright, so that's how you do that.